Hello everyone, I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this July 2025 lecture series, we are going to discuss about DFT and FFT transforms. DFT is Discrete Fourier Transform and FFT is Fast Fourier Transform. In DFT, we have DFT and IDFT. In Fast Fourier Transform, we have two methods here. One is decimation in time, another one is decimation in frequency. Shall we start? First one is discrete Fourier transforms. Consider a finite duration of signal x of n where n varies from 0 to n minus 1. Its z transform is x of z, which is equal to summation n equal to 0 to n minus 1 x of n multiplied with z power minus n. Here, evaluate at points on z plane which gives x of k, which is equal to summation n equal to 0 to n minus 1 x of n multiplied with e power minus j 2 pi by n kn. It evaluate n independent points. Remember that. Your next one is your formula become x of k, which is equal to summation n equal to 0 to n minus 1 x of n multiplied with e power minus j 2 pi by n kn. This is known as discrete Fourier transform of DFT of x of n. Here, a k varies from x of k plus pn, which is equal to x of k. This is the expected output since the spectrum is periodic in frequency. So, in discrete Fourier transform, we multiplied both sides by the DFT by e power j 2 pi by n km and add over the frequency index k. It becomes summation k equal to 0 to n minus 1 x of k e power j 2 pi by n km, which is equal to summation n equal to 0 to n minus 1 x of n summation k equal to 0 to n minus 1 e power j 2 pi by n k of m minus n. Finally, it gives the derived result x of n, which is equal to 1 by n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n kn. Here, the inverse DFT, which is x of n equal to 1 by n summation k equal to 0 to n minus 1 x of k multiplied with e power j 2 pi by n kn. Here, the DFT assumes that we deal with periodic signals in time domain, sampling in one domain, and it produces periodic behavior in other domain. C. A discrete Fourier transforms effectively by knowing x of z at z equal to zk, which is equal to x of k. X of z is known everywhere since x of z is equal to summation n equal to 0 to n minus 1 x of n z power minus n, which is equal to summation n equal to 0 to n minus 1 1 by n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n kn multiplied with z power minus n. So, our equation becomes x of z, which is equal to 1 by n summation k equal to 0 to n minus 1 x of k multiplied with 1 minus z power minus n divided by 1 minus e power j 2 pi by n k multiplied with z power minus 1. We have so much formulas. Why do we need this kind of formulas? Why do we need discrete Fourier transforms? Or else simply, what is the need of transforms here? Actually, we need to process our signals in signal processing. For example, while occurring elementary signals or ECG signal, ECG, EMG, we need to analyze our signals. We need to process our signals. So we use transforms. Transforms contains formulas. This transforms gives your final processed output in an analyzed way. For example, while considering ECG signal, we can, with the help of MATLAB, we'll produce our ECG signals. With the help of applying transforms, we can easily predict the heartbeat rate and heart disease prediction using transforms. For analyzing purpose, we use transforms here in signal processing. See, the formula is x of z, which is equal to 1 by n summation k equal to 0 to n minus 1 x of k, which is multiplied with 1 minus z power minus n divided by 1 minus e power j 2 pi by n k multiplied with z power minus 1. And while coming into the part of convolution in DFT, we consider xp of n, which implies xp of k, hp of n implies hp of k. And define and find part, we have yp of n del which is equal to idft of yp of k. See, convolution in DFT, we have yp of n. Also, we have yp of n, which is equal to one is plus and minus, and another one is plus. And the inverse of DFT is IDFT. So we need to change our formulas from plus to minus and plus. See the e power term. Okay, and finally our circular convolution formula becomes yp of n, which is equal to summation m equal to 0 to n minus 1 hp of m multiplied with xp of n minus n. And your next one is FFT algorithm. We'll discuss about FFT in next class. Thank you.